So today we have Kunal Mehta. He's going to be talking about SecureDrop. He goes by Lego KTM on the internet, and that is what you get for choosing your username when you were 10 years old, and you have to stick with it. It's factually correct. So yeah, Kunal, stage is yours.
Thank you. Hi, everyone. So yeah, I'm going to be talking about SecureDrop, a sort of Linux distro. So a little pre-intro about me. I became a Debian maintainer in 2017, and I've been a Debian developer since 2018. In Debian, I primarily maintain MediaWiki and QX, which is an offline Wikipedia reader. And I work at the Freedom of the Press Foundation since 2020. I'm very glad that FPF helped me come here, and FPF provides digital security training for journalists. We track press freedom issues in the US, and we engage in advocacy for journalists, whistleblowers, and press freedom in general. And in addition to developing SecureDrop, we also recently adopted Danger Zone, a document sanitization tool. So what is SecureDrop? First and foremost, SecureDrop is a whistleblower tip and document submission system. It's designed to facilitate whistleblowing and provide security. It's free software under the AGPL license. Anyone is free to use it, and we welcome people using it. It's both a technical and a legal tool, which I'll go into. It's powered by the Tor network. All connections to SecureDrop go through Tor. And it's based on Debian, including via Ubuntu and Tails. So SecureDrop originally started in 2011 by the late Aaron Swartz, and he created a system which he called DeadDrop. And the concept was still the same. It was a place where people could upload files or leave tips for journalists. But he never saw it fully realized and passed away before it was ever deployed. Kevin Poulsen at The New Yorker kind of took it to completion, and they announced it as Strongbox. And a few months in, around August 2013, I think, the Freedom of the Press Foundation took over SecureDrop development and has, sponsored and maintained it ever since. This is what most people see as SecureDrop. This is the source interface where sources leave tips. There's a very simple get started button and also a way for returning sources to log in to see new messages. But SecureDrop is much more than this. This is actually what I would consider the high-level overview of what a SecureDrop system is. And starting on the left side, we have the source who's using Tor browser or Tails. They connect over Tor, go through a hardware firewall, and connect to one of the application server. And then on the other side, there's a journalist, the JWS, the journalist workstation, is also connecting through Tor, downloading encrypted messages, transferring them over to an air-gapped secure viewing system, and then decrypting them, and then dealing with the messages in whichever way their newsroom chooses to go through. So now I'll zoom in on each of the individual parts and discuss in a little more detail. So the main part that we end up working on is the application server and the monitor server. And so the application server, it serves two Python web applications. One is the journalist interface, and the other is the source interface that I showed earlier. The source interface is publicly facing. It's the submission portal, and it's only accessible as a Tor Onion service. So you have to use Tor browser, and this basically helps prevent against network level attacks, and really means that on the other hand, we also don't have to worry about corporate firewalls and stuff because Tor can break through those. The journalist interface is a private interface that allows downloading encrypted submissions that journalists use. The monitoring server runs a piece of software called OSSec. It's like intrusion detection, notification, and logging stuff. And so every time specific activities happen on the application server, admins will get an email notification saying, oh, someone logged into the server, or a package was updated or something like that. Currently, these both run Ubuntu LTS, specifically Focal, and I will just disclaim that the decision to use Ubuntu was made before I joined the project because I would have chosen differently. And You can try these yourselves. We host a version on demo.securedrop.org, and you can there's an account with a standard password so you can use it to log in and just try the interface yourself. So I'm not going to go into that much detail, show screenshots of that. And then so on the journalist side, submission review. So the journalist workstation is running Tails, and if you're not familiar with it, Tails is a Debian derivative that is focused on it just runs on a USB stick. It in theory does not leave a trace on your computer that you've used it, and also all connections run over Tor. So we use Tails to download encrypted submissions, and then they're copied to an encrypted transfer drive, which is the part in the middle, and then you walk over to an air-gapped Tails machine. So the secure viewing system has the decryption key, but it's not connected to the internet. And this is for multiple reasons, but primarily, if you're accepting random files from strangers on the internet, there's a good chance that someone is going to send you malware. And so the fact that it's offline means that even if, malware starts running on your machine, it's air-gapped, so there's nowhere to exfiltrate the submission key, the decryption key to, or leak information about what else is on the viewing system. And then after that, once journalists have processed submission, it's kind of up to them on what to do next. Most places still print out documents because you can't serve malware in printer paper. But also they use Signal or other tools to stuff. But at that point, it's all in the journalist's hands on what to do. This is what it looks like in practice. There's two servers. These are Intel NUCs, and a NUC is basically just an overpowered Raspberry Pi. And there's a hardware firewall that protects both of them. One of the key things is that this is physically hosted in newsrooms. So at Freedom of the Press Foundation, we have no access to any of these. We have no insights into what's happening besides what you can see publicly, like whether it's up or down. But it's all physically hosted in newsrooms, and this gains a lot of legal protections because newsrooms have special laws and on police searching newsrooms, and so because it's physically in that boundary, you get those protections. And also, the government cannot serve in the U.S. there's a problem with government serving secret court orders against service providers like AWS and Google, and then issuing a gag order so that way they could not tell the media organization that their information had been given to the government. And so this works around that because there is no third-party provider in the mix. So if the government wants to get information, they have to serve the court order against the media organization directly. And they can still gag the media organization, but the media organization will always find out that the government is trying to get their information. But of course, this only works in countries where you can reasonably expect the police will not break down your door, which has historically been Western democracies, but even that is getting kind of sketchy. But it definitely doesn't work in a lot of countries where police do raids on newsrooms with no fear whatsoever from the legal system. And also, it's starting to get more difficult as newsrooms grow more and more remote, and there are some major publications that don't even have a physical newsroom anymore, which gives you limited options for hosting. Okay, so let's switch gears a bit and talk a bit about some of the technical features that make SecureDrop special and unique. SecureDrop is encrypted in transit, over the Tor network, and also at rest. Once your document is received, it is immediately GPG encrypted and then stored for journalists to decrypt on the offline later. Crucially, it is not end-to-end encrypted, and I'll get into that a little bit later. SecureDrop has pretty minimal metadata collection. We try to avoid collecting as much. We try to minimize all the metadata that comes in. There's only very specific things that we collect, such as when it was submitted, and that's really it. And there are a few places where we cannot minimize the metadata, and so then we obscure or fake extra metadata to overwrite stuff. There's no analytics, there's no tracking, even logging is incredibly minimal just for just like error tracebacks and stuff. We really don't want to know what's going on, and we don't want what's going on to exist on the server itself. Ultimately, SecureDrop is a very boring project, like code-wise. There's nothing novel or interesting in it, in my opinion. The tech stack is all like established software. You know, it's a Python web application using Flask and SQL Alchemy, SQLite for the database, Redis for session storage, and Apache as the web server. And we've used GPG since the very beginning, but now we're starting to replace that with this new Rust project called Sequoia PGP, which avoids some of the issues we've run into with GPG. So installing SecureDrop is a little bit complicated. Unfortunately, it's not as simple as apt install SecureDrop. It's a full operating system takeover. We have an Ansible playbook that sets up our apt repositories, the system configuration, our custom kernel, and then installs all the packages. And this happens from a Tails machine, and Tails is designed to have a very minimal stuff, so it's kind of difficult to bootstrap stuff on Tails. They don't have our signing key or the software already ready to go. So it's initially cloned from Git, and then you have to manually GPG verify it before then running Ansible. There's a detailed installation guide with lots of screenshots and pictures on the SecureDrop documentation website, and we also offer guided on-site installs. But even once that's all set up, there's a pretty crucial part that we need to protect users even before they get to SecureDrop. So we have these landing page guidelines, and if you want to leak something, right, and you DM a journalist on Twitter, and then the journalist says, "Contact me on SecureDrop," and then 2 months later, that news organization publishes this groundbreaking story, there's a clear trace that you were the person that leaked it because you messaged them on Twitter first before you got into our secure system. And so each organization that runs SecureDrop and other news organizations, have what is a landing page of how to submit tips to them. And so this is the one from The Intercept, and it explains, to use SecureDrop, take your personal computer, not your work computer, to a place with public Wi-Fi, like a coffee shop, not on your corporate network or even your home network, and then to use Tor browser. And the URL is not even a clickable link because you don't want people accidentally clicking on an onion link in a normal browser because that will leave a trace on your home network. And one interesting thing, if you notice at the bottom, it's theintercept.com/source. And there are some news organizations that initially hosted it on tips.mediaorganization.com or whatever, but because it's a subdomain, that causes an extra DNS lookup for the subdomain, which also leaves a trace. So we have specific things about it's got to be on the main domain and just in a subpath. And news websites unfortunately have tons of analytics and tracking and ads and stuff. But for SecureDrop web pages, we have them for tip pages, we have them turn off the analytics and tracking to whatever extent their software allows as possible. So oftentimes these pages will be the only pages you can visit without a trace being left. Another cool thing we've developed in coordination with the Tor browser team is short onion URLs. So the onion URL earlier, and you can see the one at the bottom, it's this giant randomized string that no one could ever remember, and even manually typing it from one computer to another is going to be incredibly difficult and error prone. So we've added short URLs. So if you go to politico.securedrop.tor.onion, it will redirect you internally to that. And initially it used the same system as HTTPS everywhere, which redirected you from HTTP to HTTPS internal in the browser itself. And so initially we used that same system to implement these kinds of rewrites. But HTTPS everywhere has been deprecated, and so now it's just built directly into Tor browser that there are these rules of redirecting one to another. And some organizations, this is an old screenshot of the Washington Post, it's just on the front page, and I know the Globe and Mail in Canada, on their print edition at the very bottom, it says, "Have a tip, send us on SecureDrop," and links to their tips pages. So there are other different ways to advertise SecureDrops. we'll switch gears a little bit, and I'll talk about some of the Debian packaging woes and successes that we've had. So the main package that we have is called SecureDrop App Code. And as the name kind of gives away, it contains the Python web application code. We do something a little weird in that we ship a virtual environment with Python dependencies inside the package instead of using like Python instead of package dependencies. This causes a number of interesting problems, namely one, that virtual environments cannot be moved. Like once you create a Python virtual environment, it hard codes the path in the environment itself, and then like renaming it or moving it is incredibly difficult. So there's a tool out there called dhvirtualenv, and I think it was originally created by Spotify, that takes care of the relocating the virtual env into the correct destination. But it was buggy, like I did the last NMU on it and like fixed 2 serious bugs, RC bugs, and it like missed the last two Debian releases ago, and it was really overkill for what we needed. So now we use this one-line sed command that I spent 10 minutes writing and perfecting, which is really great. Our package is 99% reproducible, and it's because Python packages with compiled code in them, like C code, are not reproducible, and everything else is reproducible out of the box, which is fantastic. And in Debian, it's very easy to get reproducible packages. We actually spent a lot more time getting RPMs to be reproducible. But the reason these Python wheels are not reproducible is because by default, pip builds into a randomized temporary directory, and that temporary directory, the build path, is then captured in the binary artifact. And because it's a randomized directory and changes every time, it becomes non-reproducible. And the reproducible builds team actually got some patches into GCC that implement a remapping thing that you pass it the temporary path and it uses the correct path instead, so that way it's not being captured. But Python, and pip does not use that, and injecting it is not really a feasible option. And when we talked to the pip developers about this, they were basically creating reproducible wheels is not something that pip should guarantee, that it's an installer, and recommended this other tool that they're working on called build. And so now the solution is that we build the wheels ourselves using a fixed build path. And so, this is more or less the main parts of the reproducibility code, set the source date epoch to a fixed timestamp, set a UMask that is regular, and then just set a fixed, so we still build in a temporary directory, but it's just called pip wheel build, and we use that path every time. And so the code itself just uses the build tool, but make sure to run it in that directory, and so then we don't have differing paths. This work is mostly done, but it's not yet in use, and so that'll be the next step to reach 100% reproducibility. And then the wheels are committed to a Git LFS repository, and then we have a CI step that uses repro test to verify that they are reproducible. Our tooling for this is pretty primitive. It's just good enough for our use case, but it's not generally usable. The concept is. It would be really nice if Python and pip put more emphasis on supporting reproducible wheel builds and reverse the change to build in temporary random directory. I don't think most people realize that when they download binary artifacts from pypy.org, they are not reproducible, which you would think would be a slightly more alarming problem for people. And also, from our perspective, this is kind of a self-inflicted problem. If we use Debian packages for Python dependencies, we wouldn't have this issue because Debian packages are usually reproducible. But we would have other issues, which is largely why we don't. And some miscellaneous thoughts. SecureDrop packaging has come a long way in the past 2 years, which coincidentally is when I joined the project. We previously, used dpackage deb directly to build packages via an Ansible script, which, if you're building packages, this should be this is setting off alarm bells. That's not how you build packages. It was incredibly bad, and we weren't reproducible largely because of this. And switching to the standard dpackage build package command fixed like near all the reproducibility issues except for the one temporary directory thing like right away, which was really great. Packaging tooling can be really hard to figure out for non-experts, and things like DebHelper can often feel too magical to like my colleagues. I disagree with them on this, but also I've been using it for like 7, 8 years now, so it feels pretty standard. The gap in packaging practices between unstable and focal like keeps growing. It's like different DebHelper compat versions, and also like you install systemd units differently in the old version versus the new version, and so like just keeping track of that, it just keeps getting more difficult. I want to shout out the debdiff and diffscope tools, which are really fantastic, and they help people gain confidence in what is actually being shipped to users. Historically, when SecureDrop built packages, there's an automated test that followed that would then extract the package and then verify that like all of the files that we expect to be shipped in the package were included in it. And I think for other SecureDrop developers, the deb package felt like a black box. Like you couldn't, like you had to verify that everything went in. You couldn't just know that it did. And teaching them debdiff and diffscope has been really nice because you can just diff it against the old package build, and you know exactly what changed, and that only your expected changes are in there. We have 2 primary apt repositories. We have apt-test.freedom.press, which contains nightly packages and release candidates during testing, and then we have, and it's just signed by like a key that lives on a VM in a cloud. And we have app.freedom.press, which is like the main production one. It's the one that real SecureDrops hit to download packages from. And it's signed with an offline signing key that is, secured. And then we have like an apt-QA variant, which is the same production repository, but it's just the staging area. So like we push the changes there, verify that it works, and then ship it to app.freedom.press. We use the rep-repro tool, and we commit that and the debs into just a Git LFS repository. So then updating it on the server is just as simple as git pull. And we also use rep-repro to mirror Tor packages from the Tor project app repository because the Ubuntu package is usually outdated. So this is like what our Git repository looks like, and like I mentioned, we commit the rep-repro output, so it's really nice that you can when you're reviewing the new packages come in, you can see the diff and make sure that the repository metadata is being updated in the way you expect. I mentioned earlier that we ship a custom kernel. We use the GR security hardening patch set, which provides some additional security mitigations and also disabled some features that tend to be used for exploits. We're not really kernel experts, and this tends to add a decent amount of maintenance. So our long-term plan is to switch to distro kernels. We're just trying to figure out at what point are the security features enough in the mainline kernel that we don't want to keep shipping this patch set. One ask for help is that our kernel builds are not reproducible, and in theory they could be. And so if someone is an expert or interested in helping with that, we would love to figure out how to make our builds reproducible. So I mentioned at the beginning, the title of this talk is a sort of Linux distro, and I think that's an interesting framing to think about this. Yes, this is a project that just builds on Ubuntu and Tails, but also it's kind of a distribution in its own right. And so on Wikipedia, one of the definitions it gave of a Linux distribution was that it has, application and utility software, it comes with a kernel, and it tries to meet many users' needs, and then it's combined into software packages. So really, SecureDrop meets that definition. It includes all those things. But at the same time, we don't have a lot of stuff that you would traditionally expect, a distribution to have. We don't have any ISO images, with a nice fancy installer. We don't formally do upstream package tracking. We're a pretty small team at a small organization, so we really try to benefit from existing work being done, and we enjoy standing on the shoulders of giants. We provide support to people who run SecureDrop, and the administrators are normally IT staff who may not have, who often don't have experience, running Linux systems. And so having a proper installer would sure make things nicer, but at the same time, the closer we stick to upstream, the easier it is for people to solve their problems through web searches by just saying like Ubuntu installer help, you know. So now, what is next? The future part one is the SecureDrop Workstation. And earlier I mentioned this like pretty cumbersome workflow where you download documents, on one Tails instance, you copy them over to another Tails instance that's air-gapped, then you decrypt them, and then you decide what to do with them. So we're working on a system that replaces the physical gap with a virtual one, using an operating system called Qubes. Qubes runs on the Zen hypervisor, and the idea is that it's security through isolation. Each application runs in a separate virtual machine. So this means that instead of needing a physical air gap for the decryption key, we can put it in a virtual machine that is offline and has no network connectivity. And then the client downloads the encrypted message, passes it into the virtual machine, it gets decrypted, and then the decrypted response is passed back. But the signing key is kept secure. It's currently in a pilot phase by a few news organizations that have a little more technical expertise. But it just needs to be made more robust and some more features added before we do a full rollout, which is tentatively scheduled for the end of next year. This is what it looks like. It looks like a boring standard, like chat application or email inbox. But the main thing is that the decryption happens automatically in the background. There's no manual steps needed. And crucially, we can ship software updates, including security updates, immediately. We are not, at the mercy of Tails, shipping a new release every month. So this means that users will actually, in some aspects, be more secure because they get security updates faster. And we're not limited to what's installed in Tails, because the decryption in Tails happens offline. You can't install extra software packages if you need to view some esoteric file type. Here, because we can still install software, we can make it available to view, even though it's offline virtually. And this also provides integration opportunities with Danger Zone and Signal. So you can once you receive a document, you can run it through a sanitization step before you view it. Or if you've received a document or a message and you want to send it to your colleagues via Signal, you can immediately just pop it into Signal. Like I mentioned earlier, Qubes is security through isolation. The graphical client that I showed earlier runs in real Debian VMs, which is so nice. Right now we're still running Bullseye, but we're going to switch to Bookworm hopefully by the end of the year. DOM0, which is like the virtual machine that controls all the other virtual machines, runs Fedora 32, so we have to ship RPM packages as well. But a fun fact I learned is that you can build RPMs on a Debian system, and it works perfectly fine. All of RPM is packaged in Debian, and it just works. And in case you couldn't guess, that I'm giving this presentation using Qubes OS on my laptop. So a little bit about Debian and the workstation. The switch from Buster to Bullseye was kind of painful because we delayed it a lot, and it only happened near the Buster end of life. And so we were caught unaware by package removals. So right after we switched to Bullseye, we added Bookworm to our CI pipeline well before the freeze, and we were able to find and fix at least one RC bug in the process, and also adapt our code to be ready. Honestly, stuff just works in Debian. I love it. I have not wasted time fighting with Ubuntu Pro, which is really great. And it's really nice to get more comprehensive security support in Debian because the whole archive is covered and not just the main component. Future part 2 is the next generation server. We're going to implement end-to-end encryption as just an extra security feature. And because end-to-end encryption will make the server less valuable as a target, hopefully we'll be able to install on more diverse hardware and make it easier to install. This is very much in the early planning stages still, hence 2/3 of this slide being empty is because this is all the details we have so far on what we're doing, but we're going to keep brainstorming it out and figure it out, and the main focus is on the workstation for the next year. if you want to learn more about SecureDrop, that is our main Git repository. But of course, we have like 20 different Git repositories, so but that's the main one. We have a documentation website, and then that has a good, intro and a bit of history about more history about the project. And also, we have a developer documentation website if you're interested in contributing. We have a Matrix chat room. It is kind of dead, but if you ask questions in there, we'll see it and respond. And we're also on Mastodon. And thank you for listening. This is my contact information, and I'll post the slides on the DebConf Git thing. Yeah, if anyone has any questions.
Okay. Who was first? Okay.
Just in terms of your key protection, have you looked at any way of storing them in hardware? In particular, sort of more modern laptops will have TPMs that might give you some defense in depth.
I don't know if we've looked at it, but one of the things we have right now is that one of the properties is that everything is stored on the Tails USB. And so the laptop itself is not like it. Yeah, everything is just on the USB. So if we put it in a hardware TPM, that would change that. I do think that would be an interesting thing to look at. I think we just haven't gotten to it yet.
So how the DNS records are managed for the Onion, because they are not publicly accessible. You cannot perform a NS lookup on those DNS. So how they are administered and how the SSL is issued on the behalf of those records?
Yeah, so Tor, and I'm not a Tor expert on this, it has some routing table that sends that when you have the long hash or the long crypto string, whatever, it sends that the key, it knows how to hit our Onion service. I don't know how that works. That's just a Tor thing. But strictly speaking, like TLS is not needed for Onion services because the key and the name, like all Onion service connections are encrypted. There's no like strictly need for TLS. But you can get a TLS certificate for a .onion address. It's just like an incredibly painful process. And I think the New York Times, theirs is TLS, and like you get the little padlock, but really like that's it. You just get the padlock. Like, I mean, it helps if there's a bug in Tor or something, it provides an extra layer of defense, but the process for getting a certificate and renewing it is kind of complicated. And then the short Onion name thing, so we maintain that. So in some sense, we're like a DNS registrar, but like it's literally just like an XML file with the short name and the long name, and it's signed with our signing key. And when you start up Tor browser, it'll automatically pull the rule set from the SecureDrop.org website, verify the key, and then use it. And then I think it might store it, or it pulls it fresh every time. Yeah.
Any more questions?
Thank you for your talk. Is there any particular reason why SecureDrop chooses to use Sequa PGP instead of GPG?
Instead of GPG?
Yeah.
Yeah, so we're currently using GPG. The main issue with GPG is that it was not designed to be used like as a library. Like we have to shell out to GPG, and it has this like batch mode that is, in theory, it is machine readable, but it's like very sketchily machine readable. And also there's whereas Sequoia was designed to be, first and foremost used as a library, and then they built the command line client. And so like we don't have to shell out. We can just call the code directly in Python. And I think there are other like just not misfeatures, but just things in GPG that we don't need. So to give an example, we had an issue where there was a SecureDrop instance, with quite a number of sources, and all of those keys were stored in the key ring. And every so often, GPG recalculates the web of trust, to check signatures and to see which keys are trusted or not. And we don't use that functionality. We just use the keys for encryption and decryption. And so what was happening is that it would recalculate the web of trust, but we have a 60-second web timeout, and so it would not finish in 60 seconds. The web timeout would be hit, it would be killed, the GPG process would be killed. And then the next time you tried to invoke GPG, it would try and restart it again. And so basically it just took down the entire SecureDrop for a few days until we were able to figure it out that, GPG was just rebuilding trust database. And so now we pass the flag that's like no rebuild trust DB or whatever. But it's stuff like that. Like, we just don't need it. It's just extra code that is only getting in the way. And rather than disabling features, using Sequoia as a library means that we only use the minimum subset we need, and if we need more, we can enable it.
Yeah, I've got a question to relay from IRC, from Phil. So the question is there any possibility or interest in making the server or the desktop Debian pure blend so that you could use just the Debian installer?
Sorry, could you repeat the middle part?
Yeah. Is there any interest in making the server or the desktop Debian pure blend? So basically this involves having everything packaged into Debian itself, and then having a meta package that installs all the things that you need.
That would be my long-term dream. I'd love for this to be something that you can apt install, but I think the problem is that as it is right now, SecureDrop is really like an end-to-end solution of we expect to have full control of your hardware, and we really don't want people running other things on the SecureDrop. Like, it should be just for SecureDrop, and we'll try and we turn off other things that are not needed that come by default. And really, like, it's a very special purpose application. And so yes, anyone can theoretically spin up the Python applications and throw it on a web server, but that doesn't actually provide the security benefits that doesn't necessarily provide the security benefits that SecureDrop does. And there are other projects that are designed to be whistleblowing tip submissions that are much easier to install. And Onion Share also has a spin up an open Dropbox over Tor, but it also doesn't provide the same security properties that we aim to provide.
All right, then I guess we are done with the questions. The good thing about using SecureDrop or being a whistleblower is you don't have to learn to blow a whistle. Yeah? Slave works. So yeah, thanks, man.
Yep.
Thanks for now. Great talk. So yeah, that's it. Bye, guys. Bye, all. Oh, sorry.
Thank you.